Okay, hi everyone. My name is Delane and I'm from Blocknative. Today I'll be sharing with you guys about MEV and block building, a deep dive on that, and a look at what's to come. But before we begin, Blocknative, what do, right? The funny thing is that I had conversations with some people here and they were wondering what Blocknative was. So I think this will give you a really clear view about it. So Blocknative, we've actually been running pretty robust infrastructure and set of tools for giving users access to the pre-chain layer and also to transact with confidence since 2018. And what that looks like is, a lot of people many dApps would be familiar with our wallet integration and, real-time notification tool called Web3 Onboard. We also have gas fee prediction, transaction simulation, mempool, Explorer, and APIs. And a lot of our tools are available as, APIs, SDKs, and webhooks. So we are a real infrastructure project. And if you were here on day one and you attended the Matt from Proximity Labs talk where he talked about blockchain OS, you would have heard that he mentioned using Web3 Onboard as that wallet integration tool. And Proximity Labs is not alone. If you look at NPM, we actually have over 9,000 weekly downloads of our core package for our Web3 Onboard, and that is super Saiyan cool. So we've taken that expertise in running infrastructure and expertise in mempool to this new frontier of block building. And we are now we've actually stood up our block builder since the merge, and we currently deliver about 5 to 7% of the network's blocks. And not only that, we are currently running 1 out of the 10 active relays on the network. So we've really taken a step further into Ethereum's core infrastructure. So for today, I'll talk about 3 main narratives about, firstly, why MEV matters and how MEV is created, how PBS is impacting the MEV market, and finally, share the MEV and more. So I know maybe a lot of you would have heard about MEV floating around this term, or you've been hearing about it over the past couple of months. For those who are unfamiliar with MEV, I'd like to give you a definition for the sake of this presentation. So MEV, I would define it as value derived from explicit manipulation of transaction ordering. And MEV is really interesting and important at 2 levels. Firstly, I talk about the block level, and secondly, the user transaction level. So at the block level, so why does MEV matter at the block level? Primarily because a block value is computed based on these 3 elements: transaction fees, MEV, and issuance. So let's talk about issuance first. So before the merge, when you build a block, you get a pretty significant sum of ETH issuance because the network has to pay for the power required to build those blocks. After the merge, that is no longer the case, and therefore the issuance actually dropped significantly. So this is where that ultrasound money meme came from, or that triple halvening, of issuance. So as you can see here, therefore, with the reduction in issuance and in the network, the transaction fees and MEV, or rather the influence of that at the block level has greatly increased. Then we can also look at the daily average percentage of MEV transactions in the block. If you look at this chart over here, you can see that overall the trend is going up and to the right. So MEV transactions, on average, is showing up more in our blocks. If you look at daily gas and MEV revenue, with the orange bar being MEV and the blue bar being gas fees, you can see that it's not just the daily average of MEV that's increasing. You can also see that in certain events, and this post-merge, after the merge, by the way, you can see that in certain events, the MEV revenue really spikes up, and with some days of MEV revenue even accounting for multiple days. So that's pretty wild and a very interesting development. So overall, the relative economic influence of MEV has really increased post-merge. So why does MEV matter, right? Just at the block level? Because the source of MEV is actually you and me. What do I mean? So MEV comes from transactions, and it comes specifically from end user transactions. So how does that work? So let's take a look at transactions in the mempool, or the place where transactions live before they get on chain. So over here, you can see that in this representative mempool, these transactions have different gas fees. And in naive ordering of a block, you get these transactions that are ordered from top to bottom based on the amount of gas fees that they have in that transaction. And there's no MEV here yet, it's just naive ordering. So this gets really interesting when you look at, let's say, an arbitrage example. So if we look at transaction D over here, where what transaction D is doing here in this situation is that it's moving the price on an exchange. And as a result of that, there's a price differential between two exchanges. And what this means is that it sets up an opportunity for an actor to come in and insert a transaction to neutralize or balance that difference, normalize prices, and earn some ETH as a result of their work done. So it gets complicated when you have more than one arbitrager or one actor that is trying to do so. And what happens is that there's this competition where they start to submit multiple transactions just to get into that position right behind transaction D. And as a result of that, you used to get gas wash, which is a real problem for the network. And that's no longer the case because over time there's this new solution which is called MEV bundles, proposed by the MEV Research Consortium Flashbots to help mitigate the negative externalities of MEV opportunities in this way. So MEV bundles, what happens here is that instead of just spamming the network, these actors or these MEV searchers, they send bundles to block builders, where in these bundles, they specify that, okay, I want to have my transaction come off the transaction D in this bundle, and the block builders will execute that. And as a result of that bundle, there is, let's say, an opportunity or potential revenue of $100, and it's shared with the block builder. So there's a revenue sharing situation in this ecosystem, and from that extracted value of ordering. So arbitrage is just one example. So there are different types of ordering with different types of outcomes. There's displacement or front running. There's insertion and sandwich, where you have a MEV transaction that is in front and behind the target transaction. So if you have done a Uniswap transaction, and if you are sandwiched, you have less favorable settlement. There's also suppression or censorship, where you have these multiple transactions that come in before the target transaction, and as a result, the target transaction gets pushed out of the block or does not get included in the block. So this happens during major NFT drops, where it's just wild, right? And in fact, what's interesting is earlier when I shared with you that that slide on the MEV outsized MEV revenue, that was an NFT drop event. So I know MEV sounds pretty, it's pretty uncomfortable, but it's actually everywhere. So MEV exists in all ordered transaction systems. So in the case of search engines, we all know that your search result 1 is better than search result 10, right? Because of visibility, because of click rate. And we are all pretty comfortable with the idea of search engine optimization, where essentially you manipulate search engine ranking, search engine indexing to get better ranking for your search result. And in search engines, concert ticketing, air traffic control, equities trading, there's MEV. All right? It's just that in Web3, it's open and we can see it. And this feels uncomfortable at first, but in the long run, this creates opportunity for a better systems design, precisely because we can see what is happening and we can do something about it. So a step towards better systems design is proposer-builder separation. But before we talk about proposer-builder separation, we need to first understand how block building works and how block building works, essentially. So blocks are the foundation of a blockchain, we know that. And blocks are made out of transactions that are ordered, assigned a hash, and put into a block. And those who are building blocks are considered core infrastructure, like Blocknative. Pre-merge, the mining pool operators were the ones that built the block. They built the block, and they also proposed the blocks to the network. But there was a problem with this. And the problem was that just 4 to 5 entities had the power to do so in the entire network. And this created centralizing effects where they decided the block template of the blocks and the blocks that actually land on chain. And an extension of that problem was that there was evidence of manipulation at this level, where there were offshore agreements and preferential treatment. And these entities, often they were offshore, so it was hard to perform checks and balances on them. And this ultimately went against the values of Web3. So with proposal builder separation, a fundamental change in the network happened. And I'll highlight 2 things. The first one is the role of the block builder was separated from the proposer. And now we have a new separate class of actors called block builders that build only. Then we have the role of the proposer that was adopted or combined with the validators. And if I'm sure everyone knows what a validator is, so that's what happened. So under PBS, the validator can still get their blocks built locally, but few entities would have enough resources to meaningfully do this in an efficient way, right? There are essentially 3 things that you need to do very well, right? Validate, build, and propose. And not just build, but you want to build really high value, juicy blocks. So it's really hard to do that. The alternative is that they could outsource that block construction to block builders like us. And this is completely opt-in, and it's via this sidecar called MEV Boost that was created by Flashbots. And right now, where we are at, this is proto-PBS. And the end goal, of course, is to get to enshrine PBS, but a lot of research is still being done about how we're going to do that sensibly. So how is PBS actually performing so far since the merge? If you look at mevboost.org, this is last week's data. You can check it, it's 24 hours. So 89.4% network participation is, so 89.4% of blocks are currently done through MEV Boost. And if you look at the cumulative slot share since the merge, before the merge happened, there was like around 20% slot share that the relays had. And up till now, we have now up to 80%. So what this means is that validators are opting to outsource their blocks to block builders. And for good reason, because the average block value over vanilla blocks is up 4.41x. So this is huge, right? And that's why that's the incentive. And if you look at this table over here, under the second line, average transactions included, for non-MEV Boost blocks, the number of average transactions included is 143, while the MEV Boost blocks have about, on average, 153 transactions. So what does this mean? So this means that third-party block builders are a lot more efficient in terms of including value in blocks, in sharing that value with validators, and using block space in a very optimized manner. And a large part of that value, as I shared earlier, is MEV. So who gets the value derived from MEV? So here's the situation today. So today, MEV value flows away from the transaction originators like you and I that create these MEV opportunities to the searchers and the validators. And that's because the users don't have the power to express their preferences to the network. So that's the situation right now. But we think there's a better way to approach this, that, is there a way for that value to flow back to end users? And block builders are in that position to do so because we are able to programmably express what happens at the block, right? So, and then specify what happens in the block and therefore potentially create value flows or that have that value flow back to the users. So block builders are in that pole position to create new opportunities with MEV through these programmable, expressive, fluid value flows. And block building is just really the tip of that iceberg. We block builders are here to help with MEV and create a more equitable ecosystem. But a lot of that specialization, the source of compute network is also applicable to 4337 account abstraction in the form of running bundlers. So in fact, Blocknative is currently also running a bundler on Gurley, and we're coming soon to Polygon Mumbai as well. And after account extraction, there's 4844 proto-dank sharding, where this same specialization could also come in to support activities like data availability sampling. So if you heard in Igor's talk yesterday, that's what he was talking about. And as more and more specialized actors with great sources of compute and abilities come in, you start to unlock a lot of very exciting features, such as guest sponsorships, pre-confirmation, and in the future, EPBS will take place, and so much more. So that was the block building and block building's future, but what about MEV itself? And right now, there are a couple of options being discussed around where MEV is headed, and a lot of it is still in the research and discussion phase, but out of these things, these are the three conversation paths that are happening. First one is MEV sharing, which is an example of what I shared earlier about recirculating that value back to users and creating alternate flows through order flow auctions. There's MEV burning, where you burn the MEV and you get consistent, what you reap is the consistent consensus and execution rewards. And this is also something that was mentioned yesterday in another talk as well from Nethermind's team. And finally, MEV smoothing, where you reduce MEV variance through validator pools. So that is just where we are at right now, and it's so exciting. So what can you do with this knowledge? It feels a little bit far away, esoteric even, but here's what you can do. For those who are running ETH validators, or if you're connected to a validator pool, connect to Blocknative's Dreamboat MEV Boost Relay and optimize your staking rewards. Because if you're not, you're leaving about 5 to 7% of the blocks on the table in the network. For searchers, if you can send your MEV bundles to our endpoint, that's also one thing that you can do. And for devs and builders, know that this is what it's about, what is ahead, and check out Blocknative's MEV and 4337 technologies and content. And for anything else that you would like to talk about, happy to continue our conversation offline or off stage. You can find me at Telegram, DFTDMM, and on Twitter at Delane Says. So thank you.